All right, I think we live everywhere. What's up, everybody? It's Kelvin KG.codes again. I'm doing a coding challenge lives. Hope y'all been well. Yeah, I hadn't done one of these in probably since the 15th, so I'm a little overdue. I'm gonna do a coding challenge. Work through an easy problem. This one's called Same Tree. So what I'm doing is just coding through a coding challenge from LeetCode.com. LeetCode.com is a website where you can do coding challenges that often appear in coding interviews. So like software development, software engineering role interviews. These coding challenges will show up sometimes. So you have to practice them. You have to prepare and practice for these type of interviews. So anybody that's interested in like being a software engineer, getting a software engineering job, especially at big tech companies, so like FANG companies, Facebook, Amazon, Apple, Netflix, Microsoft, Google. A lot of times they're asking these questions. The last time I was on live, a lot of the people jumped in from some FANG companies saying it like they're still asking these questions. So even in the age of AI, like these questions are still relevant. These coding challenges are still relevant. So as long as they're still relevant, and as long as companies are still asking them, I'm gonna continue to do these lives once a week and just practice a coding challenge. Hopefully it teaches people things. Hopefully it teaches me something. Hopefully it helps me practice. But hopefully this helps the community out and people that are interested in trying to learn how to code or learn how to pass these style of coding interviews. So it's an important skill to know. Hope you can hear me and everything. Hope everything's good from that end. But I think as far as everything's going, I think we're good to probably start. I might let a few people try to join up a little bit. I'm live on TikTok, live on YouTube, Twitch, TikTok, Instagram, and Twitter and X, all at the same time. So if you want to switch to a different platform and watch me there, like your preferred platform, you can do that. And yeah, we'll go ahead and just get started here pretty soon. We definitely can ask questions in the chat while I'm coding. I'll try to keep an eye on the chat to answer questions and stuff like that. But doing these coding challenges, you may not know that, but doing these coding challenges, you got to stay pretty focused to not get lost and not get confused. So I'll just bear with me. After I get done, I'll definitely answer all the questions that I can. And yeah, we'll do it like that. So I'm gonna go ahead and get started with the coding challenge. This one's called Same Tree. LeetCode.com. That's LeetCode.com. That if you want to follow along or if you want to find this website later. If you've been practicing these problems, you know that website, for real, if you're in the industry. But anyway, yeah, what we're going to do is do this problem it's number 100 on LeetCode.com called Same Tree. And the problem goes as such: given the roots of two binary trees, P and Q, write a function to check if they are the same or not. Two binary trees are considered the same if they are structurally identical and the nodes have the same value. So in example 1, they're showing the trees here. And you got to know what a binary tree is. In programming, binary tree is a data structure that allows data to be stored within it. And also there's what's called nodes and edges. So the nodes are these circles with a value stored in them. And these edges are the things that connect the nodes together. So in a tree structure, you're going to have typically, or binary tree, each node is going to have two things connected to it, which is binary, one or two, like one or the other. And so that's why it's called a binary tree. And there's different types of trees, but in this case, it's a binary tree. Every node has a left and right tree or leg to it that connects to another node, and then that connects to nodes further down. And so these examples only have trees that are one level deep, but these nodes themselves can be also connected to more nodes. And so in this first example, it's showing two binary trees, and we basically need to see if these trees are the same. The trees are they got to be structurally identical in their their structure, how the branches and stuff are. And they also got to have the same value. So each node needs to have the same value. So when we eyeball this, we can tell these two things are exactly the same. You got a 1 here in the first node. The left node here is a 2. The right node is a 3. And they're both identical. So you can see here as the input, P and Q, P is one of the trees and Q is another tree that you need to compare it with, the output we should get for these two trees is true. This example, you have one where its left node is 2, and you have one where its right node is 2, but it doesn't have a left node, and the first tree doesn't have a right node. And so in that case, P and Q actually do not equal, and I should get false. The third one is, if you just eyeball it, you see that this the 2 here doesn't equal to 1 here, and the 1 here doesn't equal to 2 there. Even though these ones are equal, you still should get false. So it's pretty simple. This is considered an easy problem on LeetCode.com, but I feel like if you haven't really done coding around trees, and if you haven't really done these type of problems before, this could be difficult. It depends on what level you're at with practicing these problems. And Gagne, I think he hopped on, he said, "You just hopping on right now. Are you going to teach how to restructure and organize a tree?" I'm just going to do this problem right now. I think I might talk about that a little bit later after I get done. More about trees. I'm trying to explain a little bit right now about binary trees, which in an interview I probably wouldn't do all this explaining, but I think it's helpful with this live for people that are trying to learn, what's going on, or get a refresher, on like how to, this type of data structure, binary trees. So I appreciate that question, Gagne. Talha27, hello KG bro, hope you're doing well. Is it a DSA problem? Yes, it is. Appreciate that question. So yeah, we're about to hop into this data structures and algorithms problem. That's what he's asking about. Would the picture be a forest? That's a good one, man. I guess I've never heard it called that, but yeah, I guess so. Nathan says, "I can't lie, can't understand what's going on." Hopefully, man, I don't know where you're at in your journey. But maybe you'll understand by the end of this. I don't know if you're a coder or if you're trying to get into it, but maybe you'll understand. A binary tree, you know what? It is kind of difficult to understand what a binary tree is and what's the purpose of it with coding. So in coding, you're usually coding around data. So think of data as in your phone, you have contacts. That's data. And let's say the contacts you make relations between those things. So let's think of this first node as your father or something like that, and let's think of 2 and 3 as 2 is you and 3 is your brother or whatever. And just think of data needing to be connected and structured in a hierarchy, some sort of way. You could think of if these are siblings, then maybe you have a parent piece of data that has edges connected to one of the brothers, one of the siblings, one of the children, and the other child and the other sibling. So I'm just giving an example, but this trees represent a way that data can be stored in an application, in a service, in a system. And sometimes data has to be stored where there are relations between each other. You think about Facebook. Facebook has something called I think they call it the grid or graph, Facebook graph. Where friends are connected in this way, where you have one friend that may be connected to two other friends, but they're not connected to each other. So Facebook needs to have a sort of a graph of what the friend connections are. So some people might be friends, some people won't. And that's how they kind of work that. That's part of how they work their system. So think of these things, why you would need these types of data structures in a programming language is for those type of reasons. So yeah, like Whittington said, his name not even Kelvin. What are you talking about, man? This is actually a fairly common question in interviews. Yeah, for sure. Well, I actually know same tree was asked a lot, but I guess for juniors maybe. But yeah, it makes sense. It makes sense. I just think it's a good problem because it's not too hard and it gets you familiar with trees, which I haven't done on here a lot. So I'm kind of starting from the easy spot with different concepts, and then as I do them a few times on here, then I'll do harder problems. But yep, this is an easy one. So some people are just gonna be like, I already know this. Other people are just maybe not really know. So you're misconstruing the two concepts. Which two concepts? I don't think so, but I could be. I don't know everything. So maybe I'm mixing something up. I don't know. But basically what I'm trying to say is that a tree, these data structures are used to hold some sort of data, and what these problems do are giving you problems around manipulating these data structures. That's what it is. The problems, like somebody on YouTube just asked, like, are these DSA problems? DSA stands for data structures and algorithms, and a binary tree is a type of data structure. So that's all I'm saying is that somebody asked what these trees are, and I'm saying it's a data structure, and data structures are used in programs and systems to hold data and store data and allow you to manipulate it based off the data structure. So I don't think I'm confusing that, but binary trees are not the same as a graph or a database. Yeah, it's not exactly the same, but I'm just giving a concept of what a tree would be used for, or what the data would be stored, like why data would need to be stored with nodes and edges. Why would there need to be connections between data points? So I think that's the same thing. So anyway, let's keep going. Let's go ahead and get through this problem. So for people that are joining now, I feel like it's a lot more, or at least a few more people join. We're doing this problem. I think y'all can read it. Basically, we need to compare these trees and see if they're the same. I'm not going to read it over again. Problem's called same tree. And yeah, they just give 3 examples of if the trees are the same. You can eyeball it pretty much, like see that these 2 trees are the same. These 2 trees are different because they have different left and right like legs, different left or right connections. And then 3 is, they're just different. The values are different. The structure is the same, but the values are different. So you're getting false for that one. The constraints. So in an interview, you may be given the constraints. You may have to ask about the constraints. As you do these problems, you get kind of used to the concept of constraints and kind of knowing, hopefully with experience, you'll learn when to ask for them. In this case, the number of nodes in both trees is in the range 0 to 100. So both trees will have 0 to 100. That's probably important because of the way that depending on how you solve the problem, the number of nodes, if you solve the problem in an inefficient way, the fact that it's capped at 100 nodes might actually help you. Like it might help you from having some sort of like stack overflow or some sort of super inefficient algorithm that, crashes your resources or whatever the case is. But it's a pretty small, 100 is not a lot of nodes at all. And the values in the nodes, that's these values 1, 2, 1, for example, it's greater than or equal to negative 10 to the 4th power or less than or equal to 10 to the 4th power. So basically what that is depending on the programming language you use, will this number here be within range of integer? Like these are just integer values, and it's just making sure whatever programming language you use, this will be important to know whether or not the range of this number can be below or above the range of the integer data type that you're using in your language. And in my case, I'm going to use JavaScript, and 10 to the 4th power and 10 to the negative 4th power isn't outside the bounds of the lowest possible integer and the highest possible integer. So I won't have any like issues like runtime errors or whatever by writing code around these numbers basically. So if you ever seen me do these before, somebody asked where you can find this. Is LeetCode.com, LeetCode.com. This is something millions of people use to do these to practice for these types of interviews. So hopefully people will find this. If people are new to it, they'll find this site and go on there and start practicing. But hopefully this is a good start for you. But anyway, so if you see me do these problems before, I like to think through the solution first and then take those thoughts and sort of try to come up with some sort of solution. Or I like to think through the problem first and then take my thoughts, try to come up with some sort of solution, and then take that solution and using the data structures and the algorithms that I've learned and approaches I've learned, try to take that to a code solution. In an interview, it's important that you talk through what you're thinking. So there's different ways to do that. You don't have to do it exactly how I do it. I'm over talking here because I'm trying to share more information than I normally would in an interview to help people. Hopefully it's helpful. But normally in an interview, you want to at least be talking so the interviewer knows how you're thinking, what solution you're going towards, what you're going to code before you start just jumping into code. I know I say that every time if you've been on here before, but it's very important that's a best practice, a generally accepted best practice for these kind of interviews is to talk through your solution, because you don't want to just jump straight to the code. And if you're wrong, the interviewer can't really help you if they don't know your thought process. If you're just coding, they're not even going to give you a hint. They're not going to really, you're not giving them a invitation sort of to help you, or any sort of like way in to help you if you don't talk through it. And so generally it is good practice to talk to your solution before you do it, and ask them, like straight up ask them, like, hey, do you think this is a good route for me? And they might help you. There's times when I've been in interviews and I'm like, I'm going down a track, and they're like, yeah, I think that's a good solution, but you're missing this piece of it. Or I don't know, maybe just think about this, and they'll maybe throw me a little hint, to kind of help me get on the right track. Did you think about this? But if you just jump to the code, you don't even give them a chance to, even if they would have. So, because once you start jumping the code, they're just like, hey, I think he know what he's doing, so I'm gonna just let him run. They're typically not gonna, like, you're in code, they're not gonna say, hey, stop, you're going the wrong way. They're not gonna give you that much of a hint. So give them a chance to help you. It's gamified, these interviews are gamified. That's typically what an interviewer is gonna expect you to do anyway. So just play the game and just make sure you do it. Just my advice. So anyway, looking at this one's such an easy problem. It's not gonna be much to talk about here. But everybody's on different levels, and I think it's important to kind of set up the best practices or whatever. So when I'm looking at this, you got to know how to traverse a tree, first of all. So like going and learning your data structures and algorithms is important before starting these problems, or at least while you're doing these problems, especially the easy ones, understanding how do you traverse a tree. So what they're going to give us in the problem is the root of the tree in P and Q. So this tree is P, this tree is Q, and will be initially stored, it's showing it kind of weird here, but what's initially stored in this P and in this Q is the head of the tree. And that's 1, 1. So they're going to give me a reference to the object, the node, at the head of these trees. It's important to know that, because if you come in this problem, you don't even know how to traverse a tree in code, or a binary tree in code, then you're kind of already lost. Like you kind of failed the battle. So it's not for people that haven't done interview styles like this. Just because you're a great coder at your day job, these skills here you may not have run into, especially if you didn't do a traditional like college education computer science degree route. You might not have run into something like this. And so it's important to practice and get these data structures down before just jumping into it. So how I'm looking at it, I'm going to write some code to traverse the tree. And it's pretty simple. I'm going to start at the node that I'm given in the programming language, which is the head of the tree. And I'm going to compare the two values in both trees. I'm going to say is 1 equal to 1. In that case, it's true. And then I'm actually going to, since it's a binary tree, it's only going to have a left and a right leg or whatever. Y'all know what it's called? What is left and the right? What do you call it? Left and the right subtree, left and the right node. I don't know what you would call it, but that's what it'd be called. That's what I'm looking at. I'm actually going to look at the left leg of each tree and then look at the right leg of each tree and also see if they're equal. And so when I jump down to here, at the same time, I'm going to jump down to here and I'm going to compare the 2 and the 2. And when I see those are equal, I'm going to say, okay, just keep going. Those are equal. Then I'm going to look at the right leg, 3 and 3. They're equal. When I see that those are equal, I'm going to be like, okay, I can continue. Once I'm done with this, if I've never ran into a case where I've saw a false or saw where they weren't equal, then I'm going to return true. Now, let's get down to this example where it's like different. when I looked at these two, they're equal. When I go down to this one and I compare these two, they're not equal. I'm going to go ahead and just say false right there because I don't need to continue after that point. And that's important logic to think about before you start writing the code, is that like I'm going to just exit out as soon as I run into a case where the numbers aren't equal. Or here, like here, I run into a case where like when I'm looking at 2 and I try to find the 2 over here, there's no 2. There's no example of in the second tree of a left node. So in that case, the structure ain't the same, just like it says up here. They got to be structurally identical and the nodes got to have the same value. So once I see that these are not equal, I'm going to go ahead and just return false and exit out of my program. Because at that point, I don't need to waste time and waste resources, waste cycles or whatever, doing more work. So basically, I would say that to the interviewer. I want to basically just traverse the tree and just check everything. Everything is equal. All the structures are equal. All the values are equal. Now, how I would do that in code is what I want to do is, and it's something that's not really intuitive. It's something you would learn from doing a lot of these problems. But I actually want to recursively do this. So recursion is basically a way of writing algorithms where you're recursively calling the same function inside of the original function. So you're calling a function inside of itself to do further work. And what that does in most programming languages is build a recursion stack, a stack of calls. You're going deeper and deeper down this stack of calls. And as every call resolves, you're basically going back up the stack as you're processing each of these functions. And you're basically stacking functions on top of stacking work on top of itself as you're going deeper recursively in the function calling itself. I know that's a terrible explanation, but it's very recursion isn't the easiest thing to explain without the definition. So, but I think you're gonna see what it looks like when I do it. And so what I want to do basically is I want to write an algorithm that when I'm checking the left and right nodes, that I can recursively pump the new node back into my same function and process it. And I just want this function to return true or false. Is this tree equal to this tree at this level, true or false? When I get down here, is this tree equal to this tree at this level, true or false? And so I want to be able to ask recursively as I go down the nodes, do I get a true when I go down that path or do I get a false? And recursively, everything as the stack unrolls, it'll eventually come back up to the top and return to me whether it's true or false. The whole thing is true or false, or it'll just exit out the program once it finds a false. And so yeah, that's the solution I'm thinking. So I talk to the interviewer. I'd say, hey, like I probably wouldn't say hey, but I'd just be like, what do you think about my solution? Do you think I'm on the right track? Should I start coding this? What do you think? They'll say yes or no or whatever. Maybe they'll help me if I'm off. I'm gonna assume that they think that my idea is good for the sake of this live, and then I'm gonna move to the code. So I think I already talked about the constraints. I know everybody's waiting on it, like it's jump to the code. I think we're good to jump over there. So I'm gonna move the screen over here. This is LeetCode.com. They also have a editor or IDE, sort of online IDE for you to write the code, and then you can also submit it to see if it's correct and all that kind of stuff. So I'm gonna use JavaScript. I know I get this every time, like why not use Python? I use JavaScript because that's what I use mostly in my day-to-day job. That's what I use mostly on interviews because I'm going for JavaScript based roles. And so that's what I use. That's my strongest interviewing language due to my career. So that's what I'm going to use. It's just as readable as Python. It's just as easy to read as Python, just as easy to write as Python. Python's a great language. I think it just surpassed JavaScript as the most popular language this year. JavaScript had it for the last 10 years, and now it's Python that has the #1 spot. JavaScript, I think, is like #2 now. They're both great languages. If you can read Python, you can read JavaScript. So just try to be, I know people going to have different opinions, like you should always use Python, but just try to be more agnostic. And if you're a good software engineer, it doesn't matter the language. You should be able to read multiple languages at some point. Like, you know, like don't just, it's no reason to pigeonhole yourself into just forcing yourself to just read one language. So we're going to do JavaScript. It's going to be great. Like, and everybody's going to understand it that understands Python. So we're going to jump into the code. Somebody said it hurts my brain to code JavaScript. Dang, man. Come on, man. Don't say that. Don't do me like that, bruh. Man, you talking too much. Just do the problem. Hey, man, I'm sorry, man. I'm trying to help explain, trying to teach some people some stuff. I'm trying to teach some people some stuff, man. Maybe I'll start going quicker through it, but then I start going quicker through it. They can be like, dude, I don't even understand what you're doing right now because you're not explaining anything. So I'm trying to find a balance, bro. Trying to find a balance. But anyway, we're going to get started on this. LeetCode, it goes ahead and scaffolds out the problem for you. So this is the function down here they want me to complete. It's the empty space in here. P and Q, like I had over here, that's what's going to get passed in, is the head of the two trees, binary trees to be specific. And also what's important is LeetCode is actually giving you the function or the object structure for how to create the object, like what the objects look like and how LeetCode is actually creating them. They're creating something called a tree node. Those are the objects. The tree nodes have a value, which equals the value, the 1, 2s, and 3s, and all that stuff, the numbers inside of the nodes. And then a left pointer to the left node and a right pointer to the right node. I don't really need to look at the rest of this. I kind of know what it is, but these are the important things to let me know how I need to write my algorithm, because that's what these tree node objects look like. And what's getting passed in is P and Q are tree nodes. And what they expect me to return is a Boolean, true or false, whether it is same tree. And so I get the P and the Q, they're gonna be tree nodes, and I need to use these different parameters or whatever on these. What is it? What, I'm blanking out on what the heck these are called on an object. But anyway, like I need to use these different things on the object in order to access the values of them and complete the algorithm. So we're gonna go ahead and do that now, based on what I was saying in my solution. And first thing I'm gonna do in JavaScript, I'm gonna change this to const, because that it's not proper to use var. Typically, it's not best practice. You usually want to use let or const when you're declaring a function or a variable because of JavaScript's hoisting. And if you use var, it's going to hoist it to the top of the global scope, and that could possibly cause issues in your software based off of like things being in an unexpected scope, overriding functions that have the same name, as well as other issues. So you don't really typically want to do that. So change it to const means that I'll get a compiler error if this gets initialized anywhere else, because it's just constant. This is the only instance of subtree of same tree is same tree. It doesn't really matter on LeetCode, but LeetCode puts that, and then somebody gonna ask me in the comments every time, like, why did you put var there? So I'm gonna change it. So anyway, now we got this P and the Q is same tree. So the first thing I want to do is, when I got the P and the Q, what was the first thing that I said I wanted to check? I need to check the structure and I need to check the value. So one thing I want to do is start thinking about my state that I want to check every time I have a P and Q. So when I have a P and Q, I'm gonna write an if statement. The states that P and Q can be in. So P can be, it can either be null, like it can have nothing in it. It could just be an empty node, just like we saw here, where they could be empty nodes. They could be populated nodes with a value in them, but the value could be different than the other one. So those are kind of the basic states, like either non-existence, existence and has the same value as the other tree, or existence and doesn't have the same value as the other tree. So those are the states. So I'm going to handle the state first, my termination state. So like when you're doing recursion, you have to think about like where do you just stop? Like where do you terminate? And for me is if both the nodes are null. So like if P does not exist or they just undefined or whatever, and Q does not exist, then I actually want to just return true in that case, because if they don't exist, then they're actually everything's fine. They're actually equal. Both trees being non-existent is actually equal in that case. Both trees or nodes. I'm sorry, not trees. The nodes in that case, because P is a node and Q is a node, just like they say here. It's not the whole tree. It's just the head of the tree to start, and it's whatever current tree node I'm on as I'm traversing. The next thing I want to check, if I find that these things both have something in them because they're both not null, or one of them does at least, then I'm going to check that P. I'm going to use this operator. This basically says in JavaScript, oh yeah, my bad. I want to put this on the top of the screen for people that jump in. So I'm putting this at the top of the screen. This is the actual problem prompt. I forgot to put that up there. But anyway, this just basically says if this is null, do not access the value. So what I want to do is just access the value through the dot notation, access val. And basically this says just don't try to access this val and cause some sort of runtime error if it doesn't exist. That's what this question mark does. But I basically want to say when I have a val, if it's not equal to Q, the value currently in Q. So basically it's saying, see if I have a P, the node itself exists. If so, take the value. If not, then it just be null or undefined, or I can't remember which. Or and see if it's not equal to the value here. This is the thing I'm trying to check as far as do these two numbers equal at every point. And so if they're not equal, like I'm checking here, then I want to return false right here. So yeah, if these two things are null, then just return true, because I'm basically kind of done with checking this branch. And then I want to check the values. If the values are not equal, then I want to return false. And then if I don't return false, then those values are equal. And I need to, what happens when the values are equal? So like in this first example, if this value 1 is equal to 1, now I need to start checking these two legs on the tree, the left and the right. And so the last thing I'm going to do if I get past that if statement is I actually want to then recursively return the value of the left and the right tree. So I want to actually recursively call is same tree, and I want to put in P left and P and Q left, and I'm basically passing those back in, the left and the right, the left of that node into same tree, and I'm going to do the same thing on that recursively. So I know this part for beginners may be tough to understand, like recursively, like recursion, and like why you would do that, what's happening, how to keep track of it in your head. It can be a little bit confusing to understand the concept of recursion if you're just trying to even understand the concept of basic coding. It's not. Some people are going to jump in and say it's easy, blah, 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 but it's not easy for people that just start out at all. Like regular coding isn't hard. Regular coding isn't easy to learn even before you get to concepts like recursion. So don't feel bad if you just don't immediately understand what's going on. And it's hard to explain too. Recursion is probably one of the hardest things to track, debug, explain, like to people that completely don't understand what's going on. Like it's easy to explain to people that know it, but that are completely new is kind of tough. So anyway, so somebody on Instagram, I know I've neglected some time, but somebody said, please keep it going through it like you are, like explaining to the level of depth. So some people appreciate it. I know some people like this is too much talking, but I think it helps, man. We need to, everybody's at different levels is basically the answer. So anyway, I'm going to do this on this side. So on the left side, I'm basically saying to hopefully explain it better. I'm basically saying when I get here and I see that these are equal, the next thing I want to do is I want to check the right and the left side of both trees together. And I can use the same function that I'm currently in to recursively do it on the next node. So that's why I was talking about state. I'm basically passing in pointers to the left and right side, and they're basically the same tree node type of objects as I originally passed in the first time is same tree is called. So they're basically two new nodes. I'm basically like starting over, but instead of starting from 1, I'm just starting from 2. And if 2 had other trees, then it would move on to the next tree and just keep recursively calling it. And so I actually, why it builds a stack is because I'm actually not returning anything until this recursion ends, until I hit one of these cases. And this recursion stops, and once the recursion stops and something gets returned, it basically returns that value that you're returning sort of back up the stack into returning out of the original function that was called from whatever it was called from, which in this case is LeetCode. And so I also need to do the other side of the tree, of course, like I said, and I'm basically anding it together and saying return if these both need to be true in order for the whole thing, the tree, to be true. And so if one of these are false, then this whole thing is false. And so I also need to check P right and Q right. Yeah, Q right. And this recursion will basically, once these get passed in, they basically start the process over. And for P left and P and Q right, I actually would check those values like, are both of them null? Return true. Do their values equal? Return false if they don't. If they values do equal, then check their subtrees as well. If they have subtrees, they may not. Check the left and the right. That sound like yin yang twins a little bit, but or Lil Jon, whatever song. I think it was Get Low where he said something like that. But anyway, getting distracted. So yeah, you check the left and the right, and then yeah, I think this is it, man. I don't know if I need to do anything else. Yeah, I'm checking the values, and then if I get here, I just recursively go through here, and I end with the true or false here. It looks fine. So if you got to this point, what I would do is I would just read my code over without starting to run it yet. I would just read and make sure that it's what I expect. Like I'm checking the values. If both of these are null, then return true, because I'm kind of done with that. And then here, I'm checking if the node exists, check the value and make sure they're equal. So if one of these don't exist, then I'm going to return false. Because if one of them doesn't exist and the other one exists, then I still get a false. If their values don't equal, then I get a false. And that's the two cases that they asked about. Are they structurally identical, and do the nodes have the same value? And so I think I'm covering that case pretty good. And then, yeah, then down here, I'm just recursively passing the next ones in. I make sure I do left and Q, left, Q, P, Q. God, P left and Q left, P right and Q right. Yeah, I think that's right. And it's an and. So, yeah, this looks good. So, basically at this point, either the interviewer would let you run the code. Some interviewers actually don't let you run the code. They would make you manually take a data set and trace through the code by hand and make sure your code works. Prove to them that your code works without even running it. Like manually tracing through the code line by line. That's what some interviews, like I think the Amazon interview, the Amazon, what they call it, the screening call. I think they made me do that without running it. And then the, I think, what other company? I think it might have been Airbnb that had a round like that where I couldn't run the code. I had to explain it by hand. But LeetCode, in some interviews, they actually have a runner, like some to execute your code in whatever language you've done it in. And it'll check it automatically, like programmatically. It will check your result, run the result sets against your code, see if you get the output that is expected for each input set. and not result sets, for each input set, do you get the output that's expected? So in our case, LeetCode, what it does is it takes example 1, 2, and 3, the input and output, and it allows you to run your code. I'm gonna actually do that first this time. Usually I run the code manually, but people seem to get bored of me doing that. But it really is important, man, to be able to trace through your code manually. And you know, I'm gonna talk about how I do it, but I'm actually not gonna do it because I know people get bored when I do it. So, but what I usually do is that I take the variables, I put comments for the variables that the input. So in this case, just start with example where the tree is 1, 2, and 3. The tree is 1, 2, and 3. I hate how they do this, how they LeetCode is putting this. It's more like 1 and then like it's kind of hard to show it like I want to, but it's more like this. This is the tree. I'm just representing the tree. So like this would be 2, 2, and this leg would be 3. It's more like a better way I feel like to represent it, but I guess programmatically, how would you represent it programmatically? Yeah, you would have to have, P would just be, actually it wouldn't even be like that. It's just a visual representation. It would actually be a tree node object where the value is equal to 1, and then left is actually equal to a pointer, which I can't really put in code, but it's actually equal to another object, a pointer to another object, which is like a whole nother one of these is what left would be pointing to. So it's kind of hard to write down. These recursion problems are actually hard to do by hand because, or sometimes they're harder to do by hand because it's, yeah, you're having to keep track of like the recursion stack too, which is kind of tough. But so yeah, I'm not gonna do this one by hand, but typically what I do is I put the variables in these, so like Q would also be the same thing. Put the variables in here and then I run line by line and I just update the variables to what their current values are. And I just make sure by the end that I get an output either like true or false or whatever the case of the problem is. And I just make sure I get that output. And I would talk through it as I'm doing it. I'll make sure the input that I have gets the output I have by going through each line of code and logically deciding what it's doing and using comments to keep track of the values at each step of the way. Because if you try to keep all the values in your head, you'll lose track of them. So I hope that makes sense. I'm not going to actually do it, but I hope it makes sense. So what I'm going to do after all that long talking, I'm sorry. What I'm going to do is press play up here. LeetCode allows you to run the problem against their system or whatever. And I'm going to see if I get the right answers for so for case 1, 2, and 3, which those are my examples that I showed you earlier in the problem description, I got accepted. So like for 1, 2, and 3, they're identical, got true. For this one, these two are not identical, I got false. These ones, they're not identical, I got false. So nice that since I reviewed my code, I think I didn't have any like runtime errors or like bugs or any kind of like weird things that would cause the program not to run. And then when it did run, I got the right answers for the test case, for the 3 test cases. And so when I got to this point, I probably get like a okay from the interviewer, and they probably immediately ask me what the time and space complexity of this solution is. And what time and space complexity are a way for us to denote how efficient our algorithm is as the size of the input scales. And so these big tech companies, they're dealing with some of the largest scale in the world, and their algorithms a lot of these problems have been solved already, but what they're trying to look for in the candidate is that they're able to optimize algorithms for very large data sets. So like here in this case, P and Q, the nodes can only be 100, but like think of it in a scale of a big company. They may deal with solutions that have inputs of very large, 100,000, millions, hundreds of millions, whatever the case. And you may have, it may not be as crude as what this problem is asking you to do, but you may have a situation where you have an algorithm that has to efficiently deal with high scale of the input that is being passed in. So big O notation denotes with time and space complexity how well your algorithm scales or performs as the data set scales up in size. And so time complexity measures how well it forms as far as number of operations, which affects the CPU usage. So how many operations is your algorithm having to run as the size of the input scales up? Is it uniform? As the input scales up, does your algorithm have a uniform number, a linear number of operations that it has to do? Or does it exponentially have to do more operations as the size grows up? That's not good. So like if it's got 1 million, you might have to do 1 million times 1 million operations, like 100 million. Or if it's 1 million input, then you just have to do 1 million operations, which isn't so bad. You're just doing one operation per, a kind of a set amount of operations linearly to the size of your input. So, and space is similar, but it's more measuring how much runtime memory, RAM, for instance, on a server, are you having to use as the size of the input grows. And so in this case, time complexity is measured by something called big O notation. That's how you that's how you denote it. That's how you write it. That's how you communicate it. And it's basically grouped into certain labels for big O notation. And you're going by worst case, and there are things you can reduce and don't have to specifically consider when denoting the big O notation, the time and space complexity, if those things are nominal as far as scale, if they don't really matter. So in this case, the size of my input is the size of these two trees. And a lot of times your constraints can help you with figuring out what the actual size of your input is. Size of my input is up to 100 nodes here. That's basically the size of my input. The size of my input isn't the numbers that are in there, but how many nodes do I have to process when my algorithm runs, which is up to 100. But let's pretend like it could be infinity. Let's pretend that it's just n. Like let's call it n. Let's give it a variable name. It doesn't have to be 100. It could be 1 million or whatever. But let's call it n. Let's give it a variable name. In big O notation, n is typically the first. It's typically a best practice to use n as the variable you use in your big O notation. And so if it's n, basically the size of this input, how many operations am I doing in relation to the size of the input? Well, I already know from how I've done this algorithm is that I'm simply processing every node. In order to see if two trees are equal, I simply have to check every node one time. And because I'm checking in my algorithm, checking both trees at exactly the same time, I'm actually doing operation per node as it relates to the size of the input. So why don't you count like each of these lines as a separate operation? Because here I'm just doing 5 different things. That's considered, these operations are considered constant as far as the size of my input goes. It doesn't matter if these are 100 or 1 million. Every time I run this line, it's just going to happen one time. Every time I run this line, it's just going to happen one time per node, And so that's considered nominal in big O notation. You don't have to consider every single thing that you're doing if they're constant operations. What you want to consider is how many times am I having to run all of these 5 lines, and I'm having to run them every time I have a new node in both of these trees. And so basically the time complexity, the number of operations, once I reduce these down, there's an operation happening every single node, and I'm checking all the nodes. So if I call the size of my nodes n, the big O notation is actually big O of n, or what's otherwise known or also known as linear time complexity. So if I'm running this on a machine, that's how many operations are going to run. As the size of this grows from 1 million to 2 billion, whatever the case, I'm still going to be running. Once reduced, I'm going to be running about 1 million operations. It's going to be more than that because of this, but in big O notation, they don't want you to say exact, like it doesn't have to be exactly the number of operations. It's fitting within a box of one of these types of time complexities. So I hope I'm explaining that well. It's kind of hard to explain, but there's also run time complexity, or my bad, I already said that one. Space complexity. And space complexity is what am I using as far as data structures, additional data structures to the one I passed in that will have to use up runtime memory, which is like the RAM on your machine. So like you think about a computer when you're running a bunch of applications on it, the applications will sometimes they'll store stuff to your hard drive, but other times they'll have operations that they're doing, logic that they're doing, that they're storing data in your actual random access memory in your RAM in order to accomplish some sort of task. And it's the same thing when you write algorithms for applications that you do at work, or you write algorithms in these crude problems, is that if you have additional data structure, it's going to use up runtime memory until this problem is complete, and your language decides to release that memory because it's done with it. And so in this case, I'm actually not building any other data structures in addition to the trees. So at first thought, you would think that I'm not actually using any additional space, but when you're doing recursion, it's something you have to kind of know and learn. When you're doing recursion, I talked about it earlier, it's actually building a recursion stack. And so every time I call this function, it's put on the stack. So when I call this function here, if I skip this step, and I get down here and I call this function recursively again, this isn't actually going to return until these two functions resolve. And so because of that, this function actually getting put on the stack. And so then when these get called, it might have to go again and call these functions again, and you have to put the second call of that on the stack. And then you just keep adding to that stack until, finally one of these actually resolves with true or false, and it starts to unroll the stack, for better lack of an explanation, or better lack of an expression for that. But it starts to pop things off the stack and dequeue the stack until it gets to the point where it returns to the first function that was called and gives the answer back to the caller of whoever called that function. And so with recursion, you actually build a stack which actually takes memory. It uses memory on your machine to build that stack. And actually, you can build a stack that is too large and actually can cause a crash on your machine if it doesn't have enough memory. Or I think some programming languages even have a recursion stack limit, I think, but I'm not sure. But they might. I don't know. But I know that you can cause problems if that stack gets tall. So basically, the recursion stack that I'm building, because I'm comparing both trees at the same time, P and Q, the stack. If the trees are really deep, the stack actually will grow to the height of my tree. So like in this case, the height of all these trees is just one. It's just like just one level. But these trees can be technically, if it can be up to 100, if I just keep going down, I don't ever split it, I just keep going down. Technically these trees, like this one, I can just keep going down. If I went down 100 nodes in each tree, I could have 100 stacks, 100 recursive calls. And so let's call that H for, you can call it N, call it H. I'm going to call it H for height in this case, because it's not actually the size of these things. It's the height of the recursion stack, basically, or the height of the trees themselves. Instead of the number of nodes in it, it's the height of the trees. So I'm going to actually call it something different. In this case, it is big O of H. And I don't know why I'm like looking down at the thing, but big old H. And so it's instead of like, it's a different variable than the actual number of nodes, which I called n. It's the height of the tree. So like where H is and the height of the tree is really the height of probably the smallest tree, because yeah, once you see the trees aren't equal, then you're just going to return false. And you're going to break out pretty quick. So it's just the height of the smallest tree. If the trees aren't equal, because if you have one tree that's one height and one other tree that's like a million, then you're just going to stop on the second. Once you get to the second one, you see that the first tree doesn't have enough in it, you'll just stop. You won't just keep processing the other tree. Well, my algorithm won't keep processing the other tree. I guess you could write an algorithm that would, but mine doesn't do that. So yeah, so you have to, the reason I'm going through all this talking about the time and space complexity, I know it sounds boring and I know it's weird or whatever. If you haven't done these problems, if you've done these and done interviews like this, you know why. But if you haven't, an interviewer will ask you this. This is the point of them asking the problem. So they will always ask you the time and space complexity if they know what they're doing. I've never had an interview where they didn't. They're gonna always ask it, because that's the point of the problems is how do you write optimal algorithms that are built for scale? And so they're gonna, it's not the only point, but it's part of the point. It's a very big part of the point. Very big part of the point. Of course, they're trying to see how you code. Of course, they want to know that you have command of the programming language that you're using. They want to know that you know how to code in general. But a big part of it is they want to know that, because you may solve the problem with an inefficient solution. And in my case, I solved it with linear. Typically, linear big old N typically is considered a good answer for an interview. A good, not answer, but a good level of time complexity and optimization for an interview. If this was what's called a big old N squared, I think quadratic time complexity, then they probably ask me to optimize. So like sometimes you'll see when you do these problems that you'll come up with a brute force solution that it's a good solution, it works, but once the size of the input starts to scale, your solution can possibly fail due to time constraints or due to resource constraints, because it's not optimal. It's like scaling exponentially or scaling quadratically as it relates to the size of the input, which isn't a good, efficient algorithm in most cases. So that's why they ask these problems, because these are big companies. This came from Google. Google's original LeetCode, data structures and algorithms types of problems, coding challenges types of problems to be specific. And because they deal with massive scale, they're one of the companies that deal with massive scale. And so they started asking these questions in their interviews, and a lot of other companies just start copying them, to be honest. And it started to kind of spread around the industry like wildfire. But not all companies ask them, but that's sort of the purpose behind why they ask these. So my bad, I'm not reading the chat. It's kind of hard to do these and read it. I'm gonna definitely read the chat in a minute once I get done. But anyway, did this problem here. It looks like I got the successful answer. Yeah. And so the other thing I can do is actually submit this against LeetCode.com. All the other people that have run this problem on here, see how I stack up, and also can look at the time and space complexity that LeetCode finds. So I'm gonna run this. Hopefully I don't run into anything. It might actually fail. Oh no, okay, it actually passed. So it ran it against 67 more test cases than the 3 I ran. So I know that it's pretty solid solution according to LeetCode standards. It says I beat 100% runtime of everybody else. I don't believe that. And my memory only beat 5%. So memory wasn't good. But I don't even believe this. You got to take these with a grain of salt. I say that every time. But yeah, you really do. Yeah, they think the time complexity similar to me is big O of N. So I think I got that part. And let's see what they say for the memory. Yeah, so they said big O of H. So yeah, they went with the H thing too, which is pretty typical for like the height of a tree. But I mean, you could call it whatever you want as long as you explain what H is and explain what N are. You could actually just do whatever you want, but you just need to need to explain it. So anyway, I'm gonna answer some questions. That looks good. Solve the problem. I'm gonna answer some questions, and then I'm actually gonna maybe think about seeing if there's another way to do this problem. But yeah, I'm gonna answer some questions first. So let's see. Yeah, my dude said, "Why aren't you reading the chat?" My bad, Sahil. Or you said, "Why are you reading?" Are you reading? Yeah, my bad, man. I'm not reading the chat. What are you asking about? Is this JavaScript? Oh, is this Python or C++? No, this is JavaScript. Are these not interactive? Yeah, my bad, man. I gotta focus, man. These things are hard to do while I'm like, I gotta think about what I'm doing. I can't get lost, man. I gotta stay focused. These problems are hard, especially in the interview. You're under pressure. So my bad. I do try to come and read the chat, but it's sort of tough. What is this code for? This code is a LeetCode.com problem. It's for practicing coding challenges for coding challenge style interviews that may be asked by big tech companies, mid-sized tech companies. Some startup tech companies will ask them to get a software engineering job. So these are questions you practice in order to get a job. So if you see at the top here, I have the question, and here I completed the code a little bit earlier. I talked about the time and space complexity. This problem is not hard. This problem is an easy problem. So yeah, I mean, people will come in here and call it easy, but that's people that have practiced these problems before and they're good at them. This problem is difficult for somebody that's just starting. So I wouldn't say that it's just hard. You look like John from RDC World. All right. I guess. I can't remember which one is John. Don't let your audience own you. Nah, yeah, hey man, they don't own me, but yeah, I appreciate you saying that. Do you have a coding job? Yeah, so I work as a principal software engineer at a mid-sized tech company. We provide chat and messaging for other companies. So if you go on Delta.com right now, you go to there's a bunch of different companies like United Healthcare, T-Mobile, Verizon. Are we on Verizon still? I can't remember. All these big tech companies. If you go in there and instead of calling and chat, or instead of calling, you actually do the chat option. My company provides the chat option for these other companies, and me specifically, I work on the chat window part of it. So I won't say too much else about my job. This ain't really about my job. It's more about me. I don't speak for my job at all. All my thoughts are my own, but that's what I do just to give validation. I've been working in the tech industry as a software engineer for over 10 years. I'm a principal software engineer at this point. So I just got promoted past senior a couple months ago. And I also was a manager before. I did management, software engineering manager before, but I'm not going to say I didn't like it, but I just changed out of it. So that's what I've been doing. Hey man, Error 1000. Oh, what's going on, man? This is my boy. I used to work with him, Dr. Insano. Error 1000 again on Twitch. Think you're streaming bitrate too high. Okay, yeah, I'll check that out, man. Maybe I do got something wrong with that. I'll chat GPT that error and see if I can change in OBS to fix that, man. My bad. I don't know what that is. Maybe that's why I don't get a lot of views on Twitch. It's because the thing is messed up. That might actually be a reason. Because I barely get any views on Twitch. I mean, I don't think anybody get views on Twitch. Twitch is hard, man. I don't know what's up with Twitch. Let's see. Let me get an interview. What's your TC range? I mean, it's up there, It's in the definitely past 100. So, and then if it's past 100 and I've been doing it for 10 years, then maybe you can guess where it's at. Just go on levels.fyi and look up engineering salaries and you'll see. I don't want to go into all the salary stuff, but you make a good living being a software engineer. Go on levels.fyi. It's a website. You can go and look up what people from different companies make and in the different states that they live in and stuff like that. So it'll give you a pretty good sense of the total compensation. That's stock plus what is it? Stock plus your base salary plus your bonus get added together, and that's what's total compensation. And you got to be at a public company to get stock. So Not all companies gonna give you stock, but most will give you a bonus in a yeah. Are you at Fang? So no, I'm not at Fang. I have passed Fang interviews before with these coding challenges. So I passed the Microsoft interview before. I passed the Amazon interview before. I decided not to go to these companies. Microsoft, I just decided not to go because I didn't like the role that they were offering. And then Amazon, they had a hiring freeze. And then by the time they came back and said, hey, man, do you want to try? They were like in that relocation thing where you got to like move to the location, like, and not work remote. And I was like, I got to work remote, man. I'm not moving. So I want to work from home still. So it was like they weren't work from home when I got the offer, but then they went hiring freeze. And then when they came back and said, hey, you don't have to interview again, we'll just hire you, but you got to move. I'm like, nah. So I could have been working at Fang. So I know that sound kind of stupid. Like, I know that sound like I'm like, no, you don't really work at Fang. Yeah, I don't, but I could have. So, and that, I think that gives a little validation. I don't know everything, man, but I at least was able to pass Fang level interviews, more than one, doing these type of coding problems. So I know a little bit of something. I don't know everything. Now, did I fail a lot of interviews? Yes, I failed. I think I failed Airbnb. I could name a whole list of ones that I failed, but I passed a lot of them too. So you're always gonna fail. People don't talk about the failures, but they always talk about the wins. So I like to talk about the failures too. Like I failed a bunch of interviews too, but I passed a grip of them as well. So thanks, pretty interesting. I'm currently working as an agentic AI software dev, but I'm trying to switch into deep learning engineer. I mean, you're already in a good spot. So I mean, yeah, whatever you want to do, seems like you're gonna be able to do it. So good luck, man, on pivoting on the pivot. Do you see? Yeah, I'm sorry. I'm trying to keep up with all the comments. What is Q? I'm gonna try to go through them a little quicker so I can get through them. Currently studying CompTIA security. Is overwhelming at times. I get it, man. It's a lot, but I want to encourage you to keep going, get that certification. I see you're trying to get into like security. So yeah, it's especially now, man, with everything with the AI and stuff, people are not trusting it as much. Security is always going to be a good tech niche to get in, niche or whatever to get into. So what types of problems do you get at work? So like I said, I work mostly on the front end. But shoot, now I guess I can't even say that anymore. I've been doing like some back end stuff now. So I guess it would be like full stack. But most of the work I get is mostly around the front end, I'd say. Working on this chat product that we have. So it's like a chat window where you can go in there and message and type with brands. So like if you got an issue with your T-Mobile service or whatever, you go in there and message with them. So mostly fixing bugs, enhancing that system. So there's new features that people want, and then there's bugs, and that's really it. And then there's like, since I'm at a principal level, I'm not working on like individual tasks as much. It's mostly around like trying to do cross-functional things with around the company. So that's like doing solution architecting, like what do we have coming up? What solutions do we need? And then like writing up documents, presenting it to the team, breaking it down into tasks, and having other developers work on it, mentoring those developers through it, helping them out with issues when things arise. So I'm mostly working on like at the principal level, you're going to be doing less coding and more architecting. And so my coding went down since I was a junior engineer, my direct coding. So which is why I still practice on here because I still want to be fluent. But also like system design is a big thing for me day to day as well. So that's a great question. Any other resources rather than LeetCode for passing Fang interviews that you would recommend? Oh yeah, man. Other than LeetCode, like and people that watch me before, they're gonna hate me because I keep bringing up Algo Monster, but it's a site called Algo Monster, Algo.monster. You see it at the top there. And this thing, man, for learning coding, like people recommend NeetCode is great, NeetCode.io. It has a list of 100 or 75 problems or whatever that are like the best to start with if you want to get a job the quickest possible, the best return on investment. Now, if you want to learn the fundamentals of data structures and algorithms before you start these problems, I recommend Algo Monster. That's what helped me have a breakthrough. I was probably 5 years of my career. I never done these style interviews. I sucked at them. And so what it does, it give you a nice flow chart of how to do problem recognition or pattern recognition. LeetCode has 3,000 problems on it. Those companies can ask you a variation of any one of those 3,000 problems. You need a strategy. You need a structure to how to answer those problems. That's what they prioritize on Algo Monster. I don't make money from them or nothing. They just really what helped me. And like here, they have this flow chart. They even like when you see a problem, it asks you questions and it helps you get to the pattern that you need to find to solve that problem. And the important part, I don't know, where is the patterns? The patterns should be on here somewhere. Where is the patterns? Yeah, I think it's this. Yeah. So I always show this every time I get on here. There's 3,000 problems on LeetCode. The patterns that you need to learn boil down to about 10, which is good news for anybody that's overwhelmed with trying to do a 3,000 LeetCode problems or even 300 LeetCode problems. Algo Monster helps you learn based on return on investment of how often these problems show up in interviews. So these green ones, they show up the most often on interviews. They're the easiest to learn, and not all of them, but some of them are the easiest to learn. And it's only 5 of them. So if you, at least as a junior, you learn these first 5 topics, you can probably start doing interviews, because it's the biggest chance that you're going to get a problem in one of these top 5 topics. And then that other chart, that flow chart I showed you, will show you how to recognize when a problem lends itself to one of these 10 topics or one of these first 5 topics. But even if you're not a junior, if you can get to this yellow section, get to dynamic programming at least, that's about as far as I got before I was able to get a job, or at least pass an interview at like Amazon, for example, like a FANG level interview. I just got to dynamic program. I didn't even do any of these last 4. I just got here. And once I knew that all the problems, for the most part, were in these first 8 sections, then it was just about pattern recognition. When I get the problem, there's certain keywords in those problems. That's what Algo Monster helps you to learn that lend themselves to those problems. So what Algo Monster does, and LeetCode does this as well, they divide the problems into these patterns, and they just like hit you over the head with those patterns. So they just drill 2-pointer solution into your these are algorithms basically. So data structures, they're going to teach you the data structures that go with these algorithms, and that's why they call it DSA, data structures and algorithms. But you're going to drill these algorithms into your head with practice problems to do, common practice problems to do, and they're just going to explain it to you as well. And the other thing I like about Algo Monster is it's text-based instead of video-based. Some people learn better by videos. If you do, I suggest you go for a different type of course. Go for YouTube course or find a course that's video-based. I like this because I can't watch videos. I start getting distracted and stuff. But I can't do videos. So I recommend Algo Monster. The other one that I see some of y'all in the comments are talking about, and I already mentioned, is NeetCode. NEET code. It's a guy. I think he's on Twitter, like popular dude on Twitter since he built this NeetCode. It does similar thing, divides everything up into different concepts, topics, and then just gives you a tree. Basically, it's not a binary tree, but basically a tree structure, and just drills these problems into your head by practicing them. And basically what he's basically going for, he's saying if you don't have a lot of time to prepare, he's just giving you a simple structure and a simple direction so you don't have analysis paralysis of where to go to answer problems. Start with arrays and hashing. Answer these problems, then move on. If you can get through at least most of this, up to backtracking especially, you probably need graphs too, dynamic programming. If you can get through these problems, then you're in a good space. So you'll have the most a high return on investment with the problems you did. He's picking problems that are coming up most often, or variations of those problems. So Neatcode.io is a good one too. So I'm gonna recommend those two because I know I stuck on that question for a little bit too long. But I think that helps probably a lot of the questions that got asked. What role was Microsoft offering you? So yeah, I didn't like the role at Microsoft because it was like not a typical programming role. I just want just a straight up software engineering role. It was like they were trying to they wanted to test me for being an engineer and they wanted me to do a lot of engineering work, but they also wanted me, it was like a hybrid DevRel role. So it was like, that's why I didn't like it. It was like I was going down, like my whole interview process was for a software engineer, but then they said part of the role was going to be DevRel, and I was like DevRel, which developer relations. So it's a great job. It's a great role. I love DevRel roles, but at that time in my career, I just didn't want that. Like I wanted to be practicing. I want to be doing 100% coding in software engineering. I want to be on a software engineering team and all that stuff. And so this was early on before DevRel was like more prominent as it is today too. And so at the time, I didn't know really what they were asking me to do. So yeah, that's why I didn't take it. But yeah. And what's crazy is Microsoft definitely they made me do leak code. That's what I'm saying. Is like I had a software engineering, because they were like, you're gonna do a lot of coding and building stuff. So had me do a software engineering interview based on my research, but I was not getting a regular software engineering job. So I'm like, that's what kind of scared me, just how they were talking about the job. They were like, well, I don't know, man. I had the feeling that it was going to be a lot less coding than they were making it out to be. But they were like, I had to do all this, like I had to go through the ringer in the interview for coding. So I don't know. I didn't like that. But I mean, that's why you leverage. Sometimes you're able to leverage your offers. So a lot of times I'm not at a FANG company, but what I've done, I'm not saying I do this on a practice, but what I do is once you get the offer from the FANG company, it's usually a lot more money. They just can pay a lot more. I'm not telling telling you what to do, but it is leverage is hard to get while you're in a job. Your best leverage is when you're coming in and when you're going out, when you're quitting and when you're getting hired. In between there, you may get a 5% raise. You may be able to get them if you talk to them enough or you got a good relationship. You may be able to give them a bigger raise, but it's rare you're going to get as big a raise as getting a new job. And so one of the things you can do if you have a good relationship with your team and with your manager is you can leverage the offers that you get from other companies to get the raise. Because now you got leverage. Like you go to them and ask, you say, I'm doing good, blah, blah, blah. We can't do it. We can't approve it, blah, blah, blah. But if you come back and say, hey, I got an offer from over here, I'm leaving. Like I said, you got the most leverage when you're coming in. You got the most leverage when you're going out. And when you get another offer, you're going out, technically. But you can decide to stay. And I know a lot of people are going to have the opinion, don't ever take a counter offer because they could have gave you the money before. I think sometimes we take it a little too personal. It's just how it works, man. It's how it works. Like it's similar to when we're coming in, we can come in with multiple offers, start a bidding war, and it's not personal. We just, hey, we're going for the most money we can get. It's the same with the company. And I'm not saying it's right. It's not right. They should pay you. And sometimes they will pay you without you having to go get another offer. But sometimes they just won't do it. And sometimes it's not personal. Like I did a counter offer like, it's like 5 years ago now. And it's fine. Like nothing ever, if people think like, oh, your boss he's gonna fire you as soon as he get the chance. If they making a counter offer, unless they wouldn't make a counter offer. If they didn't like you, they wouldn't make a counter offer. They want you to stay. So, but it's each to each his own. I get it. Like some people don't want to do that. Like I'm being disrespected. I want to get out of here. But I will say the grass not always greener. So if your only problem is the money, then you probably should stay. Because I'm telling you, I've seen people leave and they did not like it where they went. When they left for money, but they ran into non-money problems at the new job. And so I've seen it. Like I've been in the industry 10 years. I got a lot of coworkers that I still talk to. And so it's not always that simple. So I know I kind of ran it on that one. But anyway, that makes lead code less daunting. I've always been a little overwhelmed with the vast amount of problems on lead code. Yeah, appreciate it, man. Ben T. Let's see. Any more comments on TikTok? Is Meta worth it? I just had a coworker that went to Meta and he said it's great. That's the first time I met people on social media that's at Meta, but I don't really get to talk to them like I talk to him. And he really told me he's liking Meta so far. So I think Meta's good, man. I mean, a lot of people talk junk about Meta. They say it's like, they put you on those performance improvement plans or whatever, put you on PIPs, PIPs, or whatever. So, but I think every company put you on a PIP. I mean, those FANG companies, man, they trying to shuffle. So, but it probably is true. But I don't know. He's having a good time there. So I don't know. I mean, he said he likes it. I'm gonna try to not, because I didn't really ask him if I can share this. But y'all don't know who he is. But I still, sometimes people can find stuff out. But he just likes what he's doing. He likes what he's working on. He likes the people. He said the people are nice. That's a misconception that I see a lot about Facebook people. Well, I don't know if it's a misconception, but at least it's differing from what he's saying, what I hear on the internet and what I hear on Blind and on Glassdoor. But he's saying the people are really, really nice and helpful, which is totally different from what I've seen. Is bro Chinese? No, he's not Chinese. He's not Chinese. So I'm not even gonna go. I'm even gonna go there. What that is? I'm just answering the question very, simply. I don't even know why you asked that, but yeah. Will it probably be another 5 years for another raise? Yeah. So I mean, I don't think you're answering to what I was saying before, being scared. I know some people saying they're scared about doing counter offers. I just don't think. I think if they don't offer, if you bring a counter offer and they don't even respond to it, just like go ahead and go, then they telling you what they want to tell you right then. But they don't value you. But if they really value, that counter offer is coming, and they want you, and they're gonna be happy that you stayed. They're gonna be happy that you stayed. Now, if you're in a toxic situation with your boss, then don't stay. That's why the clarification I just made, if it's just about the money. If you got a toxic situation with your boss or some other, it's all this mix of stuff. Like you can't get the raise and your boss don't like you. You don't like your boss don't really know your value, like blah, blah, blah. See, but a lot of cases, man, your boss knows your value. See, it's a little bit like people take it personally with their boss. But like at a bigger company, it's not just your boss. Your boss could want to give you, I was a manager before. I wanted to give people raises, but it has to go through HR, it has to go through system, it has to go through finance, it has to go through whoever, it has to be approved. It's not always just your boss that just controls all the money. Like it's not all, some companies is like that, but most companies that I've seen and been at, it's not like that. Your boss can submit you for a raise. So if the problem is your boss not even submitting you, then just leave. Like, yeah, you're never going to get it. But if the problem is HR is their job is to protect the company and pay you as less as possible. So it was just a business thing. I'm not even seeing the people I'm talking to with HR. I gave my counter offer to my boss. They passed it on to HR, and I got the raise. I got the counter offer, and I got the raise. So it wasn't even personal between my boss. So that's the kind of stuff I'm talking about. When people just automatically just shut off counter offers, you're leaving positive outcomes on the table. If you like your team, you like your boss, you like the work you're doing, be careful about just switching jobs, man. I've seen people job hop and just never find a place they're happy at. They get to more money, but they just never happy because they're trying to go to where they think the grass is greener. The money's better. But I'm telling you, when you got to wake up and go to a job you don't like, you're going to like the money, but a job you don't like is still a job you don't like. A job that's mentally destroying you is still a job that's mentally destroying you. Like you can make all the money you want, but if you're just miserable and getting burnt out and having breakdowns and stuff, and you get on the call and your voice is shaking and you got a, teardrop on the edge of your eye and stuff. Like, you just hurting to get up and go to work. It's like money will help alleviate the pain because you'll be comfortable in your home life. But, I don't know, man. I like having, like being happy in my role. I've been burnt out before. It's not pretty. So anyway, how did you learn coding? So I went to school for coding. I went to university, got a computer science bachelor's degree. So I learned in school. That's where they just drilled it into me. Going to class, I struggled for the first couple years. Didn't really understand coding those first couple years. Just barely made it through my classes. And then one day it just clicked, man. I got into compilers class where they had us building a compiler over the course of the semester. And building that compiler, really what it was the object-oriented concept. So like we were doing Java. Yeah, Java. That was the language we were using to build the compiler in, to write the compiler in. And which is kind of crazy, using Java to write compiler for another language. But writing compilers is its own thing. But yeah, we had this like language that we were writing a compiler for, and like we're using the OOP concepts of Java, and something just about like, I figured out how the inheritance worked. I figured out some of the other principles of OOP, and it just clicked. And programming just got easier from there. Once I understood those concepts, it just was that thing that just caused a snowball effect. And then eventually I was like doing really well in my classes, like turning in projects early, and like, I was doing really well by the time I left school. And so that's how I really learned how to code. Because some people leave school somehow and they really just ain't in a good spot, or they just drop out. I've seen a lot of people drop out of computer science, man. It's one of those degrees or whatever you call what do you call it when you pick up major? It's one of those majors when I ain't been to school in a long time. I don't even know what to call it. Majors where it's one of those weeder out majors for sure. So anyway, where do you work? Where have you worked before? I think I answered that one. And everybody's low key replaceable. Yeah, man. Everybody's replaceable. So it's like, and then the crazy part, people say don't take counter offers, man. In tech, the turnover can be so crazy. People stay like 2 years, like on average or less. And so it's like the same people you worried about like doing a counteroffer with, you probably gonna have a different manager the next year. You're not even gonna have the same manager. So it's like you caring about stuff, you're like overthinking it sometimes. But I do say that, yeah, there's times when a counteroffer isn't wise. So I'm not saying it's always wise. When do you typically stream? Ben T, I appreciate that, man. I usually try to stream once a week. It's usually on Fridays, but I've been kind of slipping up on my Fridays. I'm going to try, just because you said, I'm going to try to get to like a more fixed days. But I'm on every platform streaming simultaneously. So if you follow me, turn on the notifications, all that kind of stuff. I'm going to try to like start posting when I'm going live and try to stick to consistent days. But, hopefully you follow me, DM me, man, any questions or anything, and hopefully you can stay like tuned in to when I actually go live. And you can catch me when you're free, and when you're not free, maybe you can watch the replay or whatever. But yeah, man, I hope to have you on here again, man. I appreciate all the comments you had, and everybody on here, everybody that had everybody's amazing comments. I'm sorry if I didn't get to it. There's a lot of comments, and I'm looking at. The thing I didn't explain is that I'm looking at the comments on everything. Like, so there's comments on Instagram, there's comments on TikTok, comments on Twitter, Facebook, not Facebook, what is it called? Twitch and YouTube. So I'm trying to read all the comments. The most comments are probably on TikTok. So what is your opinion of the current job market? It's a lot of doom and gloom. It's terrible right now. I had some friends that co-workers that I've called friends now, ex-co-workers, they were in the job market and it's been terrible, man. It's slow. It takes months, even for experienced devs. So I can't imagine for new devs, entry level. It's tough right now. So I'm hoping that it'll turn around in the next couple years, but there's no guarantee. Now you got AI coming into the picture. It really tanked because of the pandemic. a lot of these companies overhired during like the pandemic, like 2021, 2022. They overhired. They spent all this money, and then there was like a reverb or bounce back shock effect or whatever of the pandemic overhiring. That hurt the market first. And then right then, like 2023, ChatGPT came out, and then all this AI stuff came out, and then that started hurting the market too. Like people like, hey, I can replace these devs. I don't need as many devs as I needed before because they got AI, or I can just completely replace them, which is totally false. But CEOs say it anyway. But they definitely devs can be more productive with AI. I will admit that. Like you probably do need less devs that once you have a good AI program at your company and you have some good guidelines around it and your devs are bought into it and they're using it effectively. You might need less devs. I agree with that, but completely eradicating devs in the next 1 or 2 years, that's completely false to me. I don't believe that. But we can argue about it. I know every time I get on here, I argue with people about AI and what it's going to do. But I know I went off the track, but yeah. Dang, you on all the platforms. Yeah. So I'm on everything at the same time. So like if you want to catch me on another platform that's more convenient for you, just let me know. Yeah. Let me get an interview. We're not hiring right now. The market's terrible. I don't know if that's what you were asking. So like nobody's hiring right now, man. Like it's kind of, Facebook's hiring right now. And it's starting to get better, man. I'm starting to see companies start to hire again. I think Amazon just laid off again. So, the crazy part is I had this opportunity to go to Amazon and they've had so many layoffs. Like, I'm not sure I'd still be there. I don't even know. It's kind of weird to think about. If I went. Do you have a coding job? Yeah, I answered that one. I thought you said it was a hard one. This one isn't a hard problem that I just did. I'm going to put this thing on the screen for people that join in. I already completed the coding challenge. This thing looks so cheesy, man. I think I'm going to change this for the next stream. I had AI do this. AI is going to replace us, but AI, it do some terrible stuff sometimes. Like, this looks terrible. Like, I just try to do it real quick with AI. It looks bad. Get a master's degree in CS and just getting started with startups. So you just got a job. If you're still on here, Yusuf, tell me about why you got a master's degree and like how is that helping you find more jobs? Because I would actually like to tell people that if it helps. I never really thought a master's degree really helped that much in computer science, but I guess it depends on what master's degree you said you got one in computer science. So like, yeah, I would like to know your interest and see if it like actually, obviously it helped you. So how it helped you, and so I can start to actually tell people that, because I don't have a master's degree. I got an industry with a bachelor's, and once you get in the industry, the experience is king. So like once you get like 10, 12 years experience, it's kind of like getting a master's degree doesn't make sense. But I would like to know if starting off earlier in your career with a master's degree actually helps you, or if it helps you when you get, I don't know, it may help you anyway. I don't know. I'm just not as well versed in that aspect of it. Because I know in other industries, master's degrees have like solid benefit. Like being a teacher, a master's degree have a solid benefit. Being in these other industries, it has more of like a direct impact on your career. Coding is so interesting. I wish I knew what was going on. Yeah, man, you should learn. Like I think everybody should learn now. With AI, never been a better time to learn how to code, because AI can augment whatever learning tool you use, and you can ask it very targeted, specific questions that teach you the concepts of coding, and even can give you like little practice stuff to do, and like AI is like could be the best teacher because it can be molded to exactly what you are trying to do. So let me see on Instagram. I never checked the comments there. I appreciate it. Okay. Yeah, I don't think there's too many comments there. I appreciate anybody on Instagram that's jumped in. I went scrolling for 30 minutes and you're still on the same problem. Yeah, man. I'm talking. I took a long time to talk through it. So I'm doing the problems. Doing the problems very slowly so I can explain my thought process and help people learn. So I think I went far enough back through TikTok. And let me see what the new things are, people. Is it possible to get internships in freshman and sophomore year? Yeah, it's possible. I think I think you just have to do it well in the internship interview, probably, which is its own skill within itself. So you just got to be really focused, prepare for the interview, go online and see what those interviews look like. Go on Glassdoor, go on blind.com and ask people from the company to give you information on what the internship interview looks like. Try to find as most clues as you can. The thing is, you're in school, so like you have your I'll typically tell people to focus on school, because it's hard. Like, you got your coursework and you're trying to do your thing in school, but then you're also trying to practice for internships and make sure you pass the interviews. So just be careful, man. Just make sure you're taking care of all your bases. But I'm sure you are. So AI is taking over and saying, as an AI bachelor, I can guarantee that within 5 years, front end and back end software dev will go. I don't know, man. 5 years, that's a long time. So, it's possible. I'm typically not an AI doomsdayer with the coding thing. I just still think our jobs will change. I think we're very augmented by AI right now as software engineers. I think our jobs would more be like context engineers, where we're like giving context to the AI, managing AI agents. Somebody needs to do that job through a software engineering lens. They need to manage the coding agents, what they're doing, give it context that it doesn't have. You have a human has I have a 10-year context window, 12-year, 13-year context window. AI still has problem with context window. It's going to be, so I think we still excel at that. And so I think managing the context windows, managing the context inputs, outputs, I still think developers are still going to be needed. Now, 5 years from now, I don't know. It's kind of harder to see when you get out that far. But like next 1 or 2 years, I don't think there will be a complete eradication of engineering jobs. Like, I just don't see it. Like, according to Microsoft newly published report. See, I just posted something about that today. I don't really, companies that, like, the main people that are saying developer jobs will be gone are companies that sell AI. Like, of course they're saying that. Like, they're saying their stuff is powerful enough to replace engineers. Of course, they OpenAI, Microsoft, Google, Anthropic, like, of course that's what they're gonna say. So they're gonna promote it. Just like they had that a couple years ago, they had that Devin AI that was supposed to take over jobs, and it was all fake. And so I think it's in their best benefit to over promote or over describe what AI can do today and in the next 1 or 2 years, in order to sell their products. That's just what I believe, because I'm doing it every day, and I'm using AI every day at work, and I see where the limitations lie. And I'm not saying I know everything about AI and I'm doing everything to the maximum capacity of AI. But in order to replace devs completely, it can't be where everybody has to understand. Because what happens is I'll go online and I'll say, hey, AI can't do this, AI can't do that. You're not using it right. You're just not using the right thing. You should switch to Claude Code. You should do this. You should do that. If I gotta do all that stuff, then I'm still needed, right? You know what I mean? Like, if somebody has to make all those choices to change stuff, then I'm still needed. So what you're saying is like you're like basically kind of like crushing your own point. Like, you need to put in your instruction file and all this stuff. If I still have to do that, a software engineer is still needed. Software engineering was the roles called software developer, software engineering. It never was called programmer, or at least as far as I've been in the industry, they never hired just programmers. We're software engineers. Coding is one of the things that we do, but it's not the only thing that we do. And so there's a lot more things that go into software engineering than coding. AI is really good at coding, it's really good at answering questions, but it's not the best at context, and it's not the best. You have to give it context. And specifically LLMs, they're pre-trained. The ones that we're using, they're pre-trained from like 2 years ago or whatever the case is. They're able to get past that through context. So they have access to the internet, RAG servers. They have access to tools through MCP servers. They have access to your chat history. They have access to your MD file that you add and give it context. somebody has to be there to do those things and make decisions and make choices to the context it doesn't have. The context doesn't know about this bug from 5 years ago that I have unless something gives it to it. And so, that's just my opinion on it, man. I won't go into this whole thing because it seems like I'm like down in AI, and I'm not, because I use it every day. It's changed my life, changed my personal life, changed my professional life. It's coming. It's the future. It's going to take jobs. I understand that. But full eradication of the software engineering role, I don't see that in the next few years. I don't see it. I guess maybe in the next 5 to 10 years, maybe. I'm just not seeing it in the next 2 years. But that's just me, man. But we'll see. We'll see. I'll still be doing these lives in 2 years, because this is the last thing I'll say about it. ChatGPT came out in 2023, late 2023, and about like early 2024. Late 2023. I got on these lives and people said the same thing. In a year, AI is going to take over all the programming jobs. Then 2024 came. They had all this new AI stuff. In a year, programming jobs are going to be gone. Year comes by, it's 2025 now. Now everybody's, saying the same thing. In a year or two, all the programming jobs are going to be eradicated. So it's like, it's already been 3 or 4 years. Like, so it's like, I don't, so that's the last thing I'll say about it, man. But, yeah, man. I don't want to just keep ranting about the AI thing, because it makes it seem like I'm like I don't like AI. I love it. Within boundaries, I love it. I don't like some of it. I don't like the unsafe parts of it and the non-consent parts of it and the weird parts of it. But I do like it how it can augment my job, and I'm able to do a lot more than I was able to before. So yeah, anyway, yeah, not gone, change. Yeah. So in the sense, if you want to say in the sense that the software engineering role will be a lot different than it was before, and maybe it has a different name. I don't think the name is even going to change, because it's not programmer, it's software engineer. So whether you're using AI or you're managing AI agents, or you're simply coming in and being a human checkpoint for certain pieces of the puzzle, you're still doing software engineering. And there still need to be, the CEO of the company is not going to be doing, they're not going to be managing AI agents. They're not going to be making decisions on which AI agents we choose, how do we run them, how do we save costs, how do we manage the context window for these agents, how do we, give them the right context at the right time to save costs for the company. That's still going to be things that somebody has to do. And so, that's the stuff that software engineers do. We've always looked up information on Google. We've always copy code from other places. Like, we've never just, it hasn't always just been about coding stuff from scratch since like the 90s, before the internet, before you were reading code out of books and having to type it in, and so we always been copying code from places, Stack Overflow, Google, and so AI is just the advanced version of that, where it literally can do exactly what you tell it to do. And so it can generate code versus you just copying it. So it's a super enhancement on it. And I definitely don't want to seem like I'm downing it, because it is a game-changing thing. It's going to change things. So for every industry, not just coding. So anyway, how long you been coding? Since, professionally since 2013. So I'm old. I'm an older dude. Maybe I look younger, maybe I look older. I don't know at this point whether I look younger or older than I am. But yeah, I've been coding for a really long time professionally. And then I probably started in college, probably maybe 4 years before that, I guess you would say. And I did know how to code websites in high school, but I wouldn't say it was exactly the same type of programming and coding that I started to learn when I got in college. So Julian, man, what's going on, man? That's my boy. I used to work with him. Great dev, senior dev. I don't know what he is now. He's probably, he's principal dev. He's up there now. So I still think the laws are causing more problems than AI. Yeah, man. There's other things to get around with AI too. There's the laws, the legal things. There's the resources. So like, they're building a lot of data centers. Based on the needs that we're going to have from AI, the expected needs, we don't even have enough power to support it. Like, as far as the grid, like the power grid, we don't have enough data centers to support it. All that stuff costs money. And these companies, just because they replace devs, don't mean they save money. Like they still have to. It may be cheaper, but I don't know. Like, do the cost of AI go up? Do the cost of AI go down? Typically, cost of technology go down, but if you're talking about completely replacing millions of devs and you're running AI agents 24 hours a day and all this stuff, I mean, you look at Claude. Claude has monthly limits, weekly limits, whatever the case. You look at ChatGPT, all these AI things, they have limits because of the resources. They don't. If they had unlimited resources, they would just, if you paid enough, you could just use it forever. Even the highest plans have limits. So it's because of their technical, they can't support it. Even now, and AI isn't even heavily adopted yet. So, it's more than even the stuff I was talking about before. There's just like a logistics issue with a lot of this stuff with just mass adoption. Like they couldn't, if everybody mass adopted right now, they wouldn't even be able to support it. So, but yeah, things will change in the future. They'll get more resources. Things will get cheaper. They have more data centers, all that kind of stuff. So, anyway, that's enough rant on AI. But we had to go there, man. Like you can't even talk technical software engineering without going to AI conversation at one point. So anyway, somebody said AI generated code never looks like it can scale properly. It can at times. It's really good for greenfield development, like brand new development. You'll learn if, like, a lot of people talking on the topic ain't really been, and I don't want to talk like I'm gatekeeping or just being weird or whatever, but a lot of people that are giving opinions about AI and software development actually never been software developers. Some of them have, and they have that opinion, and I'm cool with it. But some people just haven't even done it, and they're saying they have these opinions. They never looked at a 15-year-old code base that has context that has bugs fixed with no comments in it, that you don't know why it's working like the way it's working. You don't know why they did it the way they did it. You change it, and then something way over on the other side that nobody in the company knows about, nobody possibly could have known about, breaks, and then you have an issue on your hands. The AI can change stuff like this, and it won't know. And if you don't have a human in the loop to go find that context, it may never find it. Like, because until we hook enough into the AI for the context, like I said earlier, there's certain things it can't see. And even when it has the context, that's why they have context windows. The context is not unlimited. An AI cannot run a query off of the mass of the internet at one time. Like it can't, its context can never be as huge as the human mind. Maybe one day it can, but right now it can't be as huge as the human mind. So like at my company, I've been there for a long time. There's stuff that I just have in my mental context that just right now can't be beat by AI because it just doesn't have the ability to do so. Maybe one day it does. I just don't think that's in the next 2 to 3 years. But anyway, it's absurdly powerful finding things, weird things that are in huge code base. I use it more like a search engine than a code. Yeah, like it's so good at like. Why is Siri going off? Stop. It's very good at things, man. Like it's very good at a lot of things. Like don't get me wrong. Like it's good at refactoring code. But there's issues in software development that are more than just refactoring code, more than just writing simple code. Like it's software development and software engineering is more than that. And you just have to do the job to find out about that. So, and like if you ask yourself, if you're a software developer right now, professionally, ask yourself what you thought about software engineering before you got the first job, and what you thought about it after. And how much, when you got that first job, how much your mind just blew of like how much you actually had to do in the job in addition to coding. Like how much you actually had to think about, how many bugs and problems come up that didn't come up when you're doing these little side projects. So you see a lot of tweeting on Twitter and all that stuff. But like I built this project at night and then I just vibe coded over here and I just did this. Yeah, it can do that because it's building from nothing. Like, of course, it's not gonna run into problems until it actually creates them. It has to create it first. But over time of older systems is when you start to have bugs that are very hard to, and complications in developing new features that are very hard to, that start to cause challenges. So anyway, still talking about AI. It deals with boilerplate code. Somebody asked what I was doing on here tonight. I was doing a coding challenge, but now I've completed the coding challenge. I'm just doing Q&A for a little while. Julian Facts, appreciate that, man. Some random SQL query that controls critical business logic that AI can't understand. Yeah. So it's like it may not know the depth of what it's actually changing because it just doesn't have the context. And so without a human there to review what it's trying to do or know the context or be able to go and say, okay, I need to go over here and get this context and add it to the context window for the AI. So either it can do it or I can do it myself or whatever. So anyway, how do you get your first job? How did I get my first job, or how do you get your first job in general? Oh, you said how you get your first job. So yeah, I got my computer science degree, and I just started interviewing. I took a gap year, I wouldn't call it a gap year, but after I got my degree, I took like a break doing something totally different, different type of job, and then I said, okay, now I'm gonna put my degree to work. Started doing interviews and got the job. Like, it's pretty much it. Like, I had a computer science degree, so I knew enough to start interviewing, and that was pretty much it. So went to school. Oh yeah, that during that year though, I will add, I worked on side projects and I worked on freelancing. So I built a social media app that really helped me. I added it to my resume, and I was able to talk about it in an interview. That really helped me get my first job because they were able to look at that site I built. It was a real site. It was really up. It was a social media site. They could go to it in the middle of the interview. I could talk about the database I use. I used MySQL database. I had PHP service endpoints on the back end. MySQL database. The website was a mix of PHP, HTML, JavaScript, CSS, and server-side rendering, which back in the day, that was before it came back where React server components. That back in the day, server-side rendering was like the joint. Like, that's what everybody was doing to have dynamic websites powered from the server. And so, yeah, I was doing that. And then at the job, they were doing the same thing. So it was like, dang, you know exactly what we're doing here, and you really did it. And they didn't know I just was working with my friends from high school to build this website. I had it on my resume as like I worked. It was contract work. Like, I was working for this company under a contract for a year. And so I would say that as a tip for people that's finding it hard in this industry right now to get a job, get their first job, or get a new job, is to start working on stuff. Start working on real stuff. Even if you got to build it for free, find the realer the company, the better. The company I worked for was actually a real company. It was just individuals that I knew, but it was actually like a real LLC like company. So it helps if it's like a real thing. You know what I mean? Like, it needs to be real. Put it on your resume. But you also learn while doing the project that you learn, because I was working with them, I was learning how to deal with bugs and things that I never, like when you run into bugs, when you're doing a side project on your, not side project, but tutorial projects and side projects, like just simple side projects. A lot of times when you run into a bug, you have no motivation to fix them, and you end up not fixing them. Like, you end up just quitting or whatever, moving on to something else. When you're getting paid and you're working for something, even if it's just something you set up as a freelance project or contracting, you actually have to solve the bugs, and it forces you to learn in a way that you can't learn on your own. And so that's why I suggest that as a resume booster and a training period until you can get that first job. So that's a hack in order to separate yourself from the millions of other people that are trying to get jobs with no experience. Because you can put that on your resume and say, sign a contract, start up a contract, freelance contract, and put it on your resume. I worked for this company with a contract for a year. This is what I built. Be able to talk about it, and it's a little bit of a separation. Please give me an internship. Like I said, my company, the industry sucks, man. My company, we're not hiring right now, unfortunately. So, not doing internships or anything like that right now. But hopefully one day in the future. Yeah, there's not a lot of, I don't even know where to find internships at this point, man. To be honest, it's tough. It's tough out there. Like, Amazon just had reports they were laying off recently. It's bad. Nobody's hiring in tech. Yeah, it's rough. There's still people hiring. Like, my friend just got a Facebook. One of my friends just got a contract position somewhere. So people are hiring. It just takes so much longer, man. And entry level is definitely tough, man. One of my friends was entry level when he got hired. It's a well-known company too, and I was really proud of that, man, because I was talking to him at a conference, and he was like, he was just struggling, man. He was just so bad, and I was just trying to encourage him, man. And eventually, he got a job at like a really well-known company that I was surprised they was even hiring. So it's not completely invisible, impossible, but it's happening. Meta just had a huge layout. Dang, man. Well, I don't know, man. Everywhere is struggling, man. It's rough. Do you enjoy mathematical programming? Not really. I mean, the stuff I program on at work is not mathematical. It's more about like stuff users, like user. It's chat. It's like chat. So it's messages, and the data I'm working with is like consumer stuff, like messages and users and stuff like that. Like I'm not really having to do math. There's no math in messages and stuff like that. But there's some jobs you can get where it's a lot of math. So like I'm not really in the AI side of software development. So I'm sure there's more math there if you're deeper down into machine learning and doing like building LLMs and stuff like that. But I'm actually not really interested. I'm more interested in using AI versus building the AI myself. Like I think it's a safe career position, but it seems boring. Like doing like building ALMs, I don't know. It seems fun when you release it and it seems cool because everybody's using it. But the day to day, the math behind it and the algorithms behind it, I don't know if I would have fun. I like building stuff people use. So like my stuff that I build, I see people using. I might be like overlooking somebody at a store and I might see them actually chatting with some company, and it's something I literally built, and that's my enjoyment from it, you know. Like I literally built the interface that they're using, or I worked on it at least. And so in some cases I built it. So I like that. And I mean, you're always building something somebody would use, but I just like the feeling of like being closer to what they're actually using versus like I'm just working on algorithms in the background. So that's just my personal thing. But all of it's rewarding. All of it is. All the different aspects. So anyway. You reckon the future coding is going to be replaced by AI? I just had a whole rant on that. My short answer is no. I don't think it will be completely replaced. Well, coding. You said coding specifically? Coding specifically, I mean, yeah. I mean, I could see that. I mean, I don't technically, I don't have to write a line of code myself right now. I can ask, even if it's a tiny change, I can ask AI to do it. So technically, I really don't have to do any coding myself now. But I think what we call coding is going to change. Like, software engineers are not, you know, our job isn't called coder, it's called software engineer. And so I think we're gonna be generating code through other means, which is AI. That's what I think our job is going to change to. So I think you're right. It's going to be completely replaced by AI. But yeah. Anyway, you don't think AI is taking a front end first? It's interesting. People always say that front end is easier for AI to take than back end. I don't think so. Like I think back end is easier because AI can struggle with the visual part of it. Like we see AI videos that are generated now. We see AI websites that are generated. We see AI pictures that are generated. It's always something funny in there that you could tell. Now, will it get better? Yes. But back-end code, a lot of times back-end code is a little bit more finite and deterministic. Like you get it right, you get it wrong. It's not an exact science. It's not exactly that way all the time. But it's a lot less opinionated than the front end. If I go right now and generate an AI site, some of y'all gonna like it, some of y'all gonna not. Some of y'all gonna say the button is too high up here. Some of y'all gonna say the spacing is bad. Some of y'all gonna say all this stuff because the AI really doesn't have a human eye for it. It's just trying to emulate things that it's seen before that's in the LLM that's been trained by. It's trying to emulate it, but it still can have issues. So I would actually go to record to say that back-end development is a little easier for AI to replace than front end, because front end has a little bit more of a visual aspect to it. And there's problems. There's just, I don't know, there's more problems with the browsers and just, making things look right in all the different browsers and all that stuff. And sometimes it's an eyeballing thing. Like, sometimes you're just like, no, that text is not in the middle of that button. You ask AI to center it. It tries to see that it's centered, but it still can like mess up and have little weird quirks. So I don't know. That's what I'm thinking about it. I think they both. I mean, if back end gets replaced, AI can definitely replace front end, like in a sense. But like I said earlier, I don't think any of it's getting completely replaced. But if I had to go for which one is more, I guess, up to human interpretation, it's a website, like front end stuff, website or the front end of a mobile application or the front end of a service or whatever. So anyway, it's 12, man, Eastern. So man, I appreciate all these people getting on here, especially on TikTok. There's always a lot of viewers there. Even on YouTube, there's a good amount. I appreciate y'all getting on. I think I'm gonna end it there. Please follow me on the different channels. I'm streaming all the time and posting software engineering content, tech content, YouTube, Twitch, TikTok, Instagram, Twitter, Facebook. So you can follow me on any of those channels. If I didn't get to your question, please DM me. Follow and DM me. If you DM me, we have a conversation. You can ask me any question you want. I give free advice. I don't do people homework and stuff for free, and I don't do people's projects for free. So don't come asking me to like do your homework and stuff or do your projects or whatever. But I will, I'll take a look at your stuff, answer any advice you got to help you in your career, or if you just want to bounce ideas off me, if you're already pretty experienced, just want to have a conversation about what I think about something and what you think about something. I love to hear from y'all. I love to learn from y'all. So please, connect with me outside of this, whether that's follow me or just simply DM me. Connect with each other too, man. It's a lot of smart people in the chat. It's always a lot of great people in the chats, the different chats. So connect with each other too, man. I've seen people having conversations. So, try to build a community here. So I hope that everybody connects with each other and connects with me. I will be back on here next week, hopefully Friday, but if not, it'll be either Friday, Saturday, or Sunday typically. Maybe I'll move to 2 times a week, but right now I'm good with 1 time a week, and this will be posted on my channels. I do have social media content, other types of content on my channel, like reels and shorts and long videos, short videos, images, and just stuff about the tech industry, stuff about coding, memes, informational stuff, news. I'm starting to do more news now, which it seems like it performs better. So follow me, man, and hopefully we can connect in the DMs, and hopefully y'all have success in whatever you got going on, whether it's coding, tech, IT, security, cybersecurity, or any field that you're in. I can help with you and I just wish you success and encourage you to keep going, whatever your goals are and whatever you're trying to do. So like, I'm losing my voice, so I think it's time to tap out. I really appreciate y'all for hanging in there with me, doing this coding challenge, and for the questions for the Q&A. So I hope y'all have a good week. Start the week tomorrow. I hope you have a good week, and hope you